All right, today we are going to go over part 2 of the equivalent expressions lesson, basically answering our question from yesterday, which is talking about if there is more than one possible way to have an expression for a situation. We got into it a little bit yesterday, but it is very possible to have more than one equivalent expression for a situation. So today we're going to focus on what does that actually mean to have or to say that two expressions are equivalent. So during class today, or tomorrow I guess, or whenever you're watching this video, during class in this lesson, we are going to be analyzing for students and their equations regarding the steel pieces P and the number of squares for the ladder problem. And in order to do this, we need to look at how to combine like terms within an expression or an equation. Going back to when we started working with one-step and two-step equations, I gave you the different parts of an expression and equation and what terms are. So we're going to go down here, and I've got various different expressions, and we are simply going to go over combining like terms. That means we are going to take the terms of an expression and simplify the expression based on the things that are the same, or parts that are the same. It's basically like we're going to go and combine, put the boys with the boys and the girls with the girls, or we're going to put all of the parts of an expression that are wearing the same color of jerseys together, or we're going to put all of the green pages with the green pages and all of the purple pages with the purple pages. So we're basically getting all of the different parts together, and it will simplify everything and make it shorter and more easy for us to look at, and it really will identify and help us to identify what parts are equal. If we've got more than one expression, it will help us identify which expressions are equal. So let's start with a simple one. We have 4p plus 2p. So the 4 is and the 2 are the coefficients, p is the variable, and because the 4p and the 2p, these coefficients have a variable, and the variable is the same, these are what we call like terms. Okay, because they are the same. So that means we can combine them. Okay, so if I have a 4 plus a 2, that is 6. And then we simply say P. If I had 4 pairs plus 2 pairs, I put them together, I now have 6 pairs. So the simplified version of that expression is 6P. All right, let's go ahead and go on down here to the next one, which would be 5n plus 11n. Same situation. If I took 5 groups of n plus 11 groups of n, same thing applies. 5 plus 11 is 16. N and n is the same. The variable is the same, so the n stays. If the variable is different, we couldn't combine those, but because our variable is the same, we get to combine them. All right, last one that is simple. All right, this time we have a negative v plus a 12v. This one is slightly different. Because we have a negative v plus 12, this is basically saying like we're taking away a group of v from the 12v. Again, we have no visible coefficient of v, but anytime we have a variable without a coefficient, this is like saying negative 1v plus 12v. Okay, so minus 1 plus 12. If we have 12 minus 1, we have 11v. Okay, and by doing that, we've just combined those terms together. Okay, because that in algebra, anytime there's a 1, they don't really write it, but we need to get in the habit of thinking that there is a 1 there in front of that v. it helps us. It will help us to recognize there is a 1 there. That is one group of V, whatever that V represents. All right, back up here to the top. Actually, let's just go over here to this side, and we'll go back up the other side. All right, so in this expression, we have 12r minus 8 minus 12. All right, looking in this expression, I don't have any more terms with groups of r. Okay, so 12r is already simplified, but I do have other terms that have no coefficient or no variables with them whatsoever. I have a minus 8 minus 12. For those of us that haven't worked with negative numbers yet, when I combine this subtraction of 8 and a subtraction of 12, I get a total subtraction of 20. So the simplified version of this expression would be 12r minus 20. All right, going on up. The next thing we have is a negative 2x plus 11 plus 6x. All right, so because this is all addition, we can rewrite this if we needed to. But again, we are going to combine our like terms. So the 11 doesn't have anything that's the same. Okay, we've got 6x over here, negative 2x that's over here. So essentially what we're doing, because we are subtracting this 2x and we are having 6 groups of x over here, this is like 6x minus 2x, okay, which is going to equal 4x. And then we can add in our 11. So the simplified version of that expression, after we combine our like terms, is 4x plus 11. All right, and finally, a little bit more complicated, n minus 10 plus 9n minus 3. All right, same thing apply. This n is actually like a 1n plus 9n. Okay, so let's take a look at that. We're going to ignore the negative 10 or the subtraction of 10 and the subtraction of 3. We're going to look at the 1n and this plus 9n. So both of these, that addition of 9n and this positive 1n, that would mean that we have 10 groups of n. Now, there are 2 subtraction signs here. So we're going to go ahead and leave a subtraction. Okay, we're subtracting 10 and we are subtracting 3. So we, altogether, that total subtraction that we are doing is we are subtracting 13. All right, so the simplified version of that is 10n minus 13. All right, go back, watch that as many times as you need, but I promise that when we get into the lesson tomorrow or in class, that will help us when we start checking to see if these are equivalent expressions, are equal expressions. All right, see you in class.